Okay, so I'm here to talk about OpsDev. It does exist. I have seen it on Twitter somewhere, I think, about 5 years ago. Didn't catch on. So actually, what am I here to talk about? So that's me. My name is Joe Goodings. As I say, I work for Greenpeace International. I've spent 35 years doing IT. 25 years I've been working for the Greenpeace network. I am dyslexic and neurodiverse, so any spelling mistakes, congratulations, I'll make lots of them. And if I do stumble, it's because I can't read what I wrote. It does happen. So I work for as I say, the Greenpeace network. So hopefully you may have heard of Greenpeace, but what you may not realize, it's not one organization. It's about 25 national regional offices, and they're federated. Now, Greenpeace International is the coordinating body, and that's done for two reasons. One, boots on the ground, people are local. Secondly, legal. If I was giving this talk like a year ago, there would be two little dots in Russia that no longer exist. So Greenpeace International was declared an illegal organization in Russia, campaigned about a war or something, so they didn't like it. And Greenpeace International also runs the free ships. Not quite their current coordinates, the slides gets a bit old, and they keep moving for some reason, which is really annoying, very hard to support. So I am connected to the SRE team, which was the operations team. It's a deliberately globally dispersed team, and you will see that we cover all of the time zones, and that's deliberate so that we can cover all of the time zones and all of the offices. And I think you can name most of the countries. The African one is Kenya, in case you're wondering. But yeah, and we have Brazil there, so we have Tenorio, who sits in his hammock literally up the Amazon. And then we have Oak over in Thailand, Hong Kong, Argentina, USA, Britain, and France. So why did we change? Well, there was a couple of things that were coming along. So first of all, there was a decision to move from a physical data center. So we used to have 3 physical data centers, USA, Europe, and in Australia. And so we decided they were going to move out of that and move into the public cloud and SaaS services. And that was going to be the basis of what we were going to work from. Also, this team, this operations team, was actually previously an infrastructure team, a technical applications architecture team. Previous to that, it was other teams. So over the years, people have been moved around, people have left. There was lots of technical debt. There was lots of very low response times because maybe the only person who knew that system was in New Zealand and you had sending your ticket from Washington or whatever. And so we sort of come to a conclusion that there was a lot of stuff we had to solve, and we thought infrastructure as code. That sounded good. We read it in the Metro. So we thought infrastructure as code had a certain amount of possibilities that would help us solve some of these issues that we were facing. The other issue that we were facing is very traditionally, if you look at operations, you'll see that operations carries along quite happily. Someone decides to do a project, and you get to another level, and you carry along quite happily. And those baselines can be years, months. It's a very, very slow pace when you're talking about the infrastructure side of an organization. So what the organization wants, of course, is that straight line. They want rapid change, rapid growth. So how do you get from a steps to a line? You stand on the shoulders of giants. And if anyone gets that reference, they'll know what that is in the corner, because that's integral calculus. And how do you find the area under a curve with integral calculus? Well, you make little blocks, and then you make them smaller, and then you make them smaller. And eventually you get them so small that they don't exist. And so you turn your little steps into an imperceivable amount of steps. So what did we learn on this journey, this voyage of discovery? Yes, well, you have the people, you have the processes, and you have the technology. And infrastructure as code is really only half of the answer. It's very useless unless you have the deployment mechanisms and the things around it to make it work. You can have nice Terraform on your laptop, it's still siloed if no one else can work with it. So, first of all, we had to think about the people. So, you ask someone in Greenpeace what Git is, and they'll tell you it's Greenpeace IT. I work with a bunch of Gits, and that's official. And then if you actually get to people who'd actually done anything more than download the GitHub repo and follow the README, again, you got to maybe one, maybe two people who'd actually used a sort of change, commitment sort of thing. Then if you start talking to people what a pipeline is, well, you go bound for failure after that. So what did we have to do? Well, first of all, we actually had to define what the role of the team was. We actually had to go and read up. What do they mean when they say DevOps? What do they mean when they say DevSecOps? What do they mean when they say SRE? And actually define and look at all these different things and go, well, what's the closest to what we do? We're an operations team. We don't write code. We inherited code that someone kicked over a wall or some consultant had gone and left and come back. But actually, our job was not to write code. And then you had to look at what the people who you got, what skills do they had? What skills do they need? We're a charity. We're not going to go out and hire a bunch of new people. And actually, that's very bad, and I'll tell you why in a minute. Then again, it's like, well, who's going to own this stuff? You're going to bring all this new stuff in, who's going to own it? There's education. So we have to educate not just the rest of the organization, but all the units and all the people we deal with as well. So this was the first thing we did. We actually wrote the SRE paper. So based on this road to SRE, which was a Medium article, was very good. But then we had to add on the bits that we do. We don't have a security team, that's us. When you see that thing scratched up and says, please contact your system administrator. Oh, that's me. Right. And self-service. So self-service is something that we're very keen on because that ultimately gets you to that quicker. You move at the speed of your team, not the speed of a ticket. And then we had to look at the skill sets. Also, when we wrote that paper, what we realized is a lot of stuff that we were doing that we didn't need to be doing. And that was really great because that allowed us to go back to management and say, we don't do this. And they say, yes, you do. No, we don't. Yes, you do. You know how management goes. But eventually it led to them actually starting a development team because there was all of this development stuff. And we're going, well, we can't do stuff with that, or we can. Take you 2 years. And so we were able to start actually whittling down into what was the actual core things this team was meant to do. So we got creative. We put it into tribes because, everyone needs a tribe. And then we asked people to self-identify sort of like what was your skill level, 0 to 3, in these different areas. What that allowed us to do is two things. One, those people with the highest skill levels then became the owners of those products because they were the most skilled engineers who knew how to do those things. And when we talk about pipelines, we're not talking about QA, we're talking about encoding knowledge. Yeah? So, and that's why you don't want to get rid of those old engineers, because they're the ones who know where to hit the thing when it needs to work. So it allowed us to actually identify who are the people with the knowledge, who should be making these pipelines, who had the knowledge to encode in them, so that then anyone could run the pipeline. So anyone should be able to make a change, a commit, first line support, the person at the other end, we don't really care, because the pipeline is the thing that allows it to happen. Second, it allowed us to actually then start looking at what knowledge was needed to go from one level to another level. And finally, because of this geographics that we had to cover, to make sure that we had all of the skills covered in all of the areas. And then we had to do training side. Believe me, I have a whole presentation of DevOps as a sandwich. So process. So how did we sort of get to the next step? So again, we had to dive in. What do you actually mean by continuous delivery? What do you actually mean by continuous deployment? That CI/CD bit. So after a lot of reading, Continuous delivery. Right, you have untested code, you have tested code, and you have tested code that's deployed. That's it. If you stick with that, it becomes really easy. Continuous deployment. What we want at the bottom is that continuous deployment. It's totally automated. No human beings involved. What we ended up is with, these are the sort of three situations. Most of our stuff is that top line, is that someone does some code, they test it around a bit, they do a commit, it goes into the main branch, and it automatically gets kicked out the other end. Updates are on that bottom branch. They go, we don't care. We only look at them when they fail. Very, very rarely do you have that middle branch, but there are a couple of occasions. Then you actually map that onto your ticket workflow. So SREs, operations, your support people. Yeah, you're there to hold people's hand and they cry at your shoulder when you tell them, it's gone, mate, sorry. So we had to map that CI/CD now into a support ticket flow. There's your product owners. They have a ticket. So we made a definition of a ticket. It used to work, it's now broken. That's a ticket. Everything else is an issue. We don't care. It goes into the next sprint. Yeah, Agile doesn't work for support people either. So, but once you get between whether it's a ticket, move it into sprint, move something out, or it's an issue, it gets done next week. Basically, it becomes a merge request, it becomes a branch, it goes through the loop, it gets tested, it goes into the main branch, and it goes into production, closed ticket. So, now, if you can map that onto Git, you've cracked it. And it turns out it's really easy, because that first bit, the continuous integration, is just branches. There's just 3 branches. I over-engineered this when I set it up. I could have done with 1 branch, because there's a review branch, there's a main branch, and there's a tagged release. That's it. That's your continuous integration. Continuous deployment, it's your commit message. Yep. You put those on your commit messages, then you get a little piece of thing that goes, well, okay, that's a click up 1 on the release. Real important learning point, if you do this, enforce it on the server side from day 1, because otherwise your engineers end up here. They know what they're meant to do, but they don't. So that's definitely enforce that, and then you're on your way. And as I say, then you have a piece of code that just whirs through and says, oh, I see you've got a refactor. Well, that's a patch release. Okay, you've done a, I don't know what, style change, doesn't bother with the release. And so that's how you can then map your commit messages to an actual release message and automate it. Not only does it automate that, it automates the documentation, it automates the release notes, it automates the change log. The less the engineers had to do, the more they like it, the quicker the little steps keep going. So one of the other things you have to think about is your mirror universe, otherwise known as the review environment, especially when you're talking about infrastructure, because if you start changing some of the parameters in your public cloud at the top level, you can really, really screw it up. We've done it several times. That's why we have 2. So we screw it up over here, so we don't screw it over here. We were lucky. We had this existing from a previous project. Not all SaaS services will give you a sandbox. They want you to pay extra money. No, bees. But this, and thinking about this, again, is a whole other complex thing, but you really need that to make this work. Then you want to make your ecosystem boring, because we don't want excitement. How do you make it boring? Templates. Repo templates. Everything's in there. All your commit message, all the things you don't want them to do, you put in a template. Job catalog. 90% of the jobs you run in the pipeline are the same job, apart from the encoded knowledge. Have it in one place. In fact, have it in one place in a repo, and you can update it really easily. So recently, we changed from doing Docker in Docker builds to Canico builds. We just had to change the files that dealt with the build. 600 pipelines now built in a different manner. Yay, success. Low context documentation. What does that mean? Remember at the start when I said National Regional Office? If I'd have started talking about NROs, you'd all gone, what's that? Yeah, so make that documentation really, 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 really basic. Onboarding is a lot easier. Troubleshooting is a lot easier. Style. Computer doesn't care what the style is. That's for human beings. Yeah, if everything looks the same, Again, much easier for them to read, much easier to switch between pipelines. Standards. Do Helm the same way, do variable names the same way. It's all really boring, but what it means is that any engineer can go to any pipeline and make a change. They don't spend half the day going, what were they doing? Because this is not the output. This is the thing that gets you the output. So the least time you're taking about doing anything with this, the more time you're being productive. Backups and disaster recovery. As I said, I was on the boat team of the UK for 20 years. I was up the creek without a paddle, literally. It was the Isle of Sheppey, so it wasn't quite a creek, it was a channel. I had no paddle. However, I did manage to find a shovel, which allowed me to complete. So that was my business continuity. Disaster recovery is what you do after your business continuity is working. Backups, well, that's just your point in time getting your files back. But you've now introduced a critical system. Because if this don't work, you don't work, nothing works. So you really have to think about what happens when it don't work. How do you keep it working till you get it back and work? In fact, I'd say this is more important than that. So then we get to this technology. So as I said, this is not a CI/CD pipeline. This is an automation ecosystem. What are your actual functional requirements for your ecosystem? Yeah? How does this ecosystem fit with all of the other stuff? So, you know, secrets management, drift detection, configuration management. All of these are the functions of an automation ecosystem that allows infrastructure as code to work. You can draw it out. There you go. That's my version. Then you can go and talk to the plethora of product owners and product developers. And do you need it? Do you need two of them? Do they overlap? But now, at least you have an idea of what little gaps you have to fill. I will say that when we did this, there was literally zero market for infrastructure as code. All the other code, yeah, covered. Infrastructure as code, not a hope. Integration, really bad. They all want to use their ecosystem, but their ecosystem misses a lot of what you want. And finally, for what we want to do, which is the democratization or the self-service stuff, really the licensing models don't work for that. So that's one of our hardest problems. But once you've been out, once you've looked at all the pretty products, got the swag from the show, then you can start filling in. So what does what? It also makes replacement of things really easy, because it's like, if I pull this out, I pull it out of here, I've got these gaps, I now have to fill them with something. So this is what we currently have. We have GitLab, we pay for that. We have HashiCorp Vault, we don't pay for that. InfraCost, pay for that. Chef Inspect, we're just about to pay for that because they changed the license. Semantic Release, don't pay for that. Terraform, don't pay for that. Puppet, don't pay for that. Ansible, don't pay for that. Grafana, don't pay for that. And Renovate, don't pay for that. So what does it look like? Well, when it all works perfectly, there I see that every 6 hours Renovate runs, and it's look, HashiCorp have released a new version of Terraform. It makes a merge request, it kicks off a pipeline. That's the thing at the top. It goes through the tests, all the tests works. Yay! Right, merge that into the main branch. There's the main branch, goes along, updates the documentation, goes to the release. That's the semantic release. It goes through all the commits and says, this is a 0.1 release. Yay. Then it commits a tag. That's where it gets difficult, having a pipeline that commits to itself, but it can be done. Commits the tag back to itself with the updated documentation, and then that causes the tag release, which goes into production. I think that in total is about 10 minutes of pipeline work. No humans were involved, and that goes on every pipeline. And the way HashiCorp tends to release their stuff like once a month, that means 600 pipelines, 600 updates. We only deal with the stuff that doesn't work. What did we learn? Ooh, I'm running out of time, so this is pretty much the last slide. So these are some of the things learned. IAC is not the same as application code, in my view. It's an ecosystem. It's knowledge encoding. If you ever move to cloud and SaaS services, they change much more frequently than on-prem. If you're not prepared for it, you will really suffer. You have to invest time in it. It's now a critical system. You have to treat it like a critical system and do all the critical stuff. And there we go. Questions?